Section 10.2, Regression. Given a collection of pair sample data, the regression line can also be called the line of best fit or the least squares line, is a straight line that best fits the scatter plot of the data. The equation of the regression line is y hat equals b of 0 plus b1 times x, where b1 is your slope and b of 0 is your y-intercept. Y hat is the predicted y value for a given x value. X is the independent variable and y hat is the dependent variable. In this section, we are going to learn how to find the equation of a regression line. For a sample statistic, y hat equals b naught plus b1x. For the population parameter, y equals beta naught plus beta 1x. This is for sample, this is for population. The requirements for finding the regression line: 1. The sample pair XY data is a random sample of quantitative data. 2. We need to look at the scatter plot of the sample data and see if the points approximate a straight line pattern. 3. Outliers can have a strong effect on the regression equation, so remove any outliers if they are known to be errors. The formula to find the slope: b1 equals r times the sample standard deviation of y over the sample standard deviation of x. Formula to find the y-intercept: b naught equals the average of y minus b1 times the average of x. However, we will use StatCrunch to find these both. Round b1 and b naught to 3 significant digits. Example 1. Use technology to find the equation of the regression line in which the explanatory variable or x variable is the chocolate consumption and the response variable or y variable is the corresponding Nobel laureate rate. To find the regression line, it is very important to have the correct x and correct y. In this case, they say x is the chocolate consumption and y is the Nobel rate. From section 10.1, I said when find r, it doesn't matter which one is x, which one is y, you will have the same r. However, for the equation of the regression line, it does matter which one is x and which one is y. So always pay attention to the problem so that you can have the correct x and correct y. And I will use StatCrunch to find my equation of the regression line. To find the equation of regression line, click on Stat, Regression, Symbol linear. X is chocolate and y is Nobel. Compute. This is my linear regression line. This is what I got from StatCrunch, and this is my equation of regression line. Independent variable is chocolate, so chocolate represents x. Dependent variable is Nobel. Nobel represents y. Y equals negative 3.157 plus 2.473 times x. So what I would do is replacing chocolate with x and Nobel with y hat to get to my equation of regression line. I round my slope and my y-intercept to 3 significant figures. However, always read the instruction to see how many decimal places they want you to round. Example 2. Graph the regression equation y hat that found in example 1. I am going to use StatCrunch to graph this. If you want to look at the graph of the line, you can click on this arrow. They have the scatter plot and also the line that's graphed for you. The dots are my scatter plot of the pair data. The red line is my best fit line or regression line. The equation of this line was found in the previous example. Y hat equals negative 3.16 plus 2.47x. This line is just the model of the data. If I want to estimate the y value for any given x, I will use this line. For example, if I want to know when x is a, what is y? I don't have the actual y, but I can estimate it by plugging a in here to get to the predicted y. These points are the actual x and y. The point on the line is the predicted y value. Strategy for prediction values of y. When I need to predict y values, I will ask myself if the regression equation a good model to use. If it's a good model, then I will use the equation y hat to predict my y value. If it's not a good model, then I will use y bar to predict my y value. How do I know if my regression equation a good model? First, I will graph my regression line to see if the line fits the points well. Second, I will find R to see if there is a linear correlation. Third, the prediction is not much beyond the scope of the available sample data. That means that your x value that you are going to use to get prediction on y value is in between the smallest x value and the largest x value. Example 3. Use the chocolate Nobel data from example 1 to predict the Nobel rate for a country with chocolate consumption of 10 kilograms. Chocolate consumption of 10 kilograms, which means my x is 10. And I want to use the regression equation that I found earlier to make the prediction when x is 10. Regression equation, y hat equals negative 3.16 plus 2.47x. In order to use this to make a prediction for my y value, I need to make sure that this is a good model. So how do I know if this is a good model? The first thing I'm going to do is look at this graph. This is the graph of my regression line, and it looks like that this is a best fit line for the whole data. My R value is 0.7995. This is closer to positive 1. Or I can also look at the p-value right here is less than alpha. So there is a linear correlation between chocolate and Nobel. The value that I am going to use is 10. I make sure that this 10 is in between the available data of x values. So I'm going to go back to look at the original data set. My minimum x value is 0.7. My maximum x value is 11.9. 10 is in between 0.7 and 11.9. To predict the Nobel rate when x is 10, I am going to substitute 10 in for x. Y hat equals to 21.54. What does that mean? It means that when x is 10, the predicted y is 21.54. This is not the actual y value. This is only the predicted y value using this model right here. In a scatter plot, an outlier is a point lying far away from the other data points. Pair sample data may include one or more influential points, which are points that strongly affect the graph of the regression line. For example, this is the original data from the chocolate and Nobel problem. There's no outlier, there's no influential point. Imagine that I'm now adding a new point into this data. The new point has the x value of 50 and y value of 0, which is this point right here. So once I added this point in here, it will change my regression equation dramatically. Then this is called influential point. In general, if there is an influential point in a data, you should remove it before you continue with the problem. For a pair of sample x and y values, the residual is the difference between the observed sample value of y and the y value that is predicted. So basically, the residual is your observed y value subtract the predicted y value, which is y minus y hat. So, for example, this is the regression line. This is where you get your predicted y value. These are your observed y value. When x is a, y is 4. When x is 12, y is 24. When x is 20, y is 8. When x is 24, y is 32. So, for example, when you have x is 8, y is 4 right here. The predicted y is when x is 8, you get y hat equals 1 plus 8, which is 9. So your residual is 4 minus 9, which is negative 5. And every point will have its own residual. A straight line satisfying the least squares property if the sum of the squares of the residuals is the smallest sum possible. For example, the residual here is negative 5. Residual here is 11. Residual here is 7. And residual here is negative 13. If I take the residual negative 5 square plus 11 square plus 7 square plus negative 13 square, the answer to this sum will be the least of the sum of the residual square. Then this will be the best fit line. Example 3. From example 1, we found that y hat equals negative 3.16 plus 2.47x. So from example 1, chocolate is my x and the Nobel rate is my y. This y hat is the predicted y value. A. Predict the Nobel rate for a country with chocolate consumption of 8.8 kilogram. So what I would do is take this 8.8 and substitute the in for x to find my predicted y value. And I got y hat equals 18.576. Since the original data only have one decimal place, I would round it to one decimal place to match with my original data. However, you should always read your instruction to see how many decimal places you should round to. 18.6. This is the predicted Nobel rate when the chocolate consumption is 8.8 kilogram. B. What is the actual corresponding y value when x is 8.8? Remember, this is only the predicted y value. It's not the actual y value. So I'm going to look into the table to find where x is 8.8. When x is 8.8, y is 12.7. So this 12.7 is my actual y value, or the observed y value. C. Find the residual. Residual equals y minus y hat, which is 12.7 minus 18.6. And I got residual equals to negative 5.9. Example 4. Listed below are the systolic blood pressure measurements obtained from the same woman. Find the regression equation, letting the right arm blood pressure be the predictor x variable. Find the best predicted systolic blood pressure in the left arm, given that the systolic blood pressure in the right arm is 100. Use the significance level of 0.05. The question asked me to find the regression equation, which is the y hat equation. I need to identify my x and my y variable. In this case, they gave it to you. They say, use the right arm blood pressure be the x variable, which means the left arm is the y. However, what if they don't tell you? There's a secret way to figure out which one is x, which one is y. So when you read the question, when they say find the best predicted blood pressure in the left arm, they want you to predict the blood pressure in the left arm. That means the blood pressure in the left arm is your y. Whatever you want to predict, that is going to be your y. And then the other one is going to be your x. I will use StatCrunch to go ahead and find my regression equation. Stat, regression, simple linear. X is the right arm and y is the left arm. Compute. This is your regression equation. And if you want to see the graph of the equation with a scatter plot, just click on this one. They graph that for you. This is what I got from StatCrunch. Independent variable is the right arm, so right arm is my x. Dependent variable is my left arm, so left arm is my y. And this is my regression equation. Y hat equals 31.46 plus 1.34 times x. I rounded to 2 decimal places here. However, you should always read the instruction. The question wants me to predict the pressure in the left arm if the pressure in the right arm is 100. Which means they say when x is 100, what is your y? Or what is your predicted y value? So, I am wondering if I should use this equation in order to predict the y value when x is 100. Before I make a decision, I need to make sure if this is a good model, right? So I can only use this equation if there is a linear correlation between the blood pressure of the left arm and the right arm. So I'm going to ask myself, is there a linear correlation between left arm and right arm? And I need to answer this question. It's going to be a yes or no, right? If I answer yes to this question, then I will use this equation to predict my y value. If I answer no to this question, then I will use y bar to predict the y value. How to answer this question? How do I know if there's a linear correlation? I need to look at the R value and the P value. I always use the P value to confirm my answer, because even though R looks like that is close enough to 1, however, this P value is 0.0827. This is greater than 0.05, which is the most used alpha. When P value is greater than alpha, there's no linear correlation between the two variables. So, there is no linear correlation between the left arm and right arm. So to answer this question, is there a linear correlation between left arm and right arm? No. That means I cannot use this y hat to predict my y value. I have to use y bar. Now, how do I find y bar? Remember, my y values are 177, 172, 140, 143, 143. To find y bar, I add all of them up and divide by 5. Example 5. Find the regression equation, letting the overhead width be the predictor x variable. Find the best predicted weight of a silt if the overhead width measured from a photograph is 2.1 centimeters. Can the prediction be correct? What is wrong with the predicting the weight in this case? Use a significance level of 0.05. So the question asked me to find the regression equation, and they want me to predict the weight when the overhead is 2.1 centimeters. And they want me to use alpha of 0.05. In this case, they already told me that the overhead width is x, which means the weight is y. However, if they don't tell you, then when you read the question, they say, find the best predicted weight. They want to predict the weight. That means weight is your y, which means the other one should be your x. I will use StatCrunch to find my regression equation first. Stat, regression, simple linear. X is my overhead width and y is my weight. Compute. This is the equation of regression line. And if you want to see the graph of the equation, click here. This is what I found from StatCrunch. Independent variable is the overhead width, which means the overhead width is my x. Dependent variable is the weight, which means the weight is my y. This is my regression equation. Next, I want to predict the weight when the overhead is 2.1 centimeters. In order to use this model to predict, I need to ask myself, is there a linear correlation between the overhead width and the weight? If I answer yes to this question, I will use y hat to predict. If I answer no to this question, I will use y bar to predict. In order to answer this question, I need to look at my R and my P value. R is 0.94 and P value is 0.0051. p-value is less than 0.05, so there is linear correlation between the overhead width and the weight. So yes, there is linear correlation. That means I can use y hat to predict the weight when the overhead width is 2.1 centimeters. I substituted 2.1 in for x. Predicted y value is negative 81.341. I am going to round it to 2 decimal places. However, you should always read the instruction. So when the overhead width is 2.1 centimeters, the predicted weight is negative 81.34. How could the weight be negative 81? Can the prediction be correct? No, the prediction was negative. The weight cannot be negative. It doesn't make sense. Then what is wrong? If you look at the x values, my minimum x value is 7.2 and my maximum x value is 9.4. The good x value to use is the value in between 7.2 and 9.4. However, I use 2.1. This is beyond the scope of the available sample data.